So good afternoon, everyone. I'm Lincoln, and this is my colleague and co-presenter, Hui. Welcome to this sharing session about grand-scale big data in real time. For those of you who have worked with large amounts of data, you know how tedious it can be to do analysis, especially due to the sheer amount of steps that need to be taken in order to get the output. With the help of geospatial technology, we can filter and organize big data so it can be analyzed and visualized from a spatial and temporal perspective. This helps us to reveal patterns, trends, and relationships without the need to write even a single line of code. So here's a brief overview of what we'll be covering for this session. Firstly, I will introduce you to grand-scale big data and its implications. This will be followed by a demo of how geoanalytic tools enables the consumption of this grand-scale big data. Then I will pass the time to Hui, who will go through the geoanalytic server, the data sources that it can consume, and the architecture behind it. Finally, we'll wrap things up by summarizing the need for big data geoanalytics. So the first question we may ask is, what is grand-scale big data? It may seem pretty self-explanatory, really, but let's try to break it down into qualitative and quantitative terms. When we talk about big data, we are mainly referring to 4 V's: volume, velocity, variety, and veracity. Volume has got to do with the sheer size of data, whether it's in thousands, millions, or even trillions of points. Velocity has got to do with the rate of influx of data. What's the rate of us retrieving the data? Are we doing it daily? Are we doing it monthly, or even hourly, or every minute? Variety has got to do with data sources that are available for our disposal. It could be shapefiles, it could be KML, it could be XML data. And finally, veracity, which has got to do with the sheer sporadic behavior of the data itself. Let's take a look at quote by Gary King from Harvard University's Institute for Quantitative Science. He says that big data is not about the data. What this essentially means is that data on its own does not do much for us. It is through appropriate analytical tools that we can add value to this data and make sense of it. You know that our world is undergoing a massive digital transformation in which everything is automated, monitored, measured, and recorded, and ultimately connected to the vast network that is the Internet of Things. We're generating and collecting a lot of data from a multitude of platforms, from embedded electronics, software, sensors, actuators, and this is all linked by our network connectivity. According to Gartner Incorporated, a technology and advisory corporation, there'll be nearly 20.8 billion devices on the Internet of Things by 2020. This translates to 20.8 billion devices that have the ability to capture data. The amount of data which is going to be collected is just going to exponentially rise. Now that we know what grand-scale big data is, how do we start to make sense of this data? So we have this 6-step approach for doing this. We start off by understanding. This involves giving a spatial and temporal context to the data. Then we move on to measuring, which is giving geometry to the data. This involves shape, size, and distribution. Then we move on to determining how places are related by quantifying proximity, coincidence, intersection, overlap, visibility, and accessibility. Then we move on to finding the best location and paths, such as site suitability, or even doing network analysis to find the shortest distance between 2 points. Next, we move on to detecting and quantifying. This involves pattern recognition, and it can be used to find hotspots, outliers, find natural data clusters, and analyze the changes over time. And lastly, we move on to spatial analysis, which lets us use powerful modeling techniques to make predictions and explore future scenarios. Most of the time, data needs to be refined to meet the purpose of analysis. By giving context to our data, we can perform better analysis. So GIS can help you transform big data into big insights, because location data is everywhere, and using the power of analytics, you can unlock the true potential of your data and find answers. Now it's time for a demonstration. So let's have a look at the data that we have. We have from LTA traffic data. Let me give you a bit of context to the data we have here. So LTA collects traffic speed data at sections of roads, and the speed is categorized into bands. The data we have here belongs to speed band 1, which is in which the traffic speed is less than 20 kilometers per hour, indicating slow traffic. This data is being retrieved every 7 minutes, and we have consolidated this data for time steps of 1 hour. So we have about 40,000 points every hour, translating to about 15 million points for the span of 14 days. Next, we move on to a tool that we're using to do some analysis. This is an aggregate point tool. So aggregate points allow us to see the total number of occurrences of this slow traffic within that hexagonal bin. So anyone has any idea why some of these areas are darker than the others? Give you a few seconds to think about it. Okay, one reason could be that they are closer to highways and junctions. Another analysis tools we can use is hotspot analysis. So hotspot analysis, while the previous tool that we use, aggregate points, lets us do absolute analysis. Using hotspot analysis, we can do comparative analysis. So the red here signifies the statistically significant cluster of features with high values, while the blue signifies statistically significant cluster of features with low values. This allows us to do a comparative analysis for bins in neighboring areas. There is an add-in for ArcGIS Pro called the Spacetime Cube Explorer. Here we can do visualization in both spatial and temporal terms. So each cube here represents an hour. The darker the cube, the higher the number of occurrences of slow traffic in that 1 hour time slot. This allows us to visualize the data in spatial and temporal terms. We can then use this data to do another analysis, which is emerging hotspot analysis, which I'll talk about in a while. So this is emerging hotspot analysis. This allows us to do the same spatial and temporal analysis, but what it does is it compiles the data for the entire time frame and represents it in the following visual means. So we have many categories like consecutive hotspot, persisting hotspot, intensifying hotspot, oscillating hotspot, diminishing hotspot, and sporadic hotspots. This allows us to make predictions for future, possible future scenarios. If you have a look here, this is the intensifying hotspot here, the pinkish area. What it indicates is that in the future, this might end up becoming a persisting hotspot, and appropriate steps can be taken to mitigate this from happening in the future. So now let's do a comparison between the traditional method of doing analysis versus the geoanalytics method of doing analysis. In the traditional method, if we take the big data, we have to split it by time frame. Then we have to create polygonal bins for aggregate boundary, run the aggregate tool, join the results and merge all of the outputs, set symbology for the feature layer, and then and only then can we do the analysis. Using geoanalytics tool, all we have to do is run the aggregate tool, and we can focus the rest of our time on just the analysis. Do remember that for the traditional method, we have split the data into time frames. So what we are doing is repeating the task over and over again for the number of time frames you have split it into. Now I'll pass the time on to my co-presenter, Hui, who will talk about geoanalytics data again.
Thank you, Lincoln. So basically, let's take a look. What exactly is ArcGIS Big Data Analytics? The geoanalytics server is now part of the platform, so ArcGIS has a new way of processing spatial and temporal data, and is designed for big data by leveraging distributed analytics and storage. It will work with your existing GIS data, and of course your new big data that's coming in and wherever you're storing it. And basically the whole beauty of it is you're actually using familiar workflows to complete complex analysis. You can run it from your desktop directly, or if you're familiar with the web, you can run it from a browser, just access the tools. And of course, if you are a programmatic person, you can actually run everything through API calls as well. So let's see how we actually went through getting those results that we showed you just now. So essentially what you see on the left is your familiar desktop, can be ArcGIS Pro. So first of all, what you need to do is attach the data. Send the command so that the geoanalytics server will actually pick it up and do the analytics in the background. And essentially the results are delivered through the portal directly down to your Pro or any of your other end user devices like browsers. So now, more than ever, ArcGIS is a true analytics platform. What you have is access to out-of-the-box tools that will make geoprocessing and spatial analysis faster. It also allows you to scale out to grand scale, which can be hundreds of thousands or millions, thousands or millions or even billions of observations. So at the 10.5 release of ArcGIS, we introduced the geoanalytics server. It lets you integrate various disparate data sources, use the power of distributed computing so that you can actually process large volumes of data in a matter of minutes or hours instead of, like running a job and then coming back over the weekend and finding out whether the thing actually processed or broke down. And the best part of all of this is that you can actually do everything from your familiar desktop environment. Let's take a look. What kind of analysis can you do? So essentially, in terms of analysis, the analysis capabilities, the tools actually let you focus mainly on spatial temporal analysis, like I was saying. These, for now, mainly involve general summarization and aggregation, and they can be either time-dependent or time-independent. So when you have access to the geoanalytics tools, these are the main tools that you will see. In terms of summarizing data, you have what we showed you just now, the results, the aggregate points, joining features, reconstruct tracks. You have to remember that this is actually all on a grander scale, not just whatever data you have on your desktop. And of course, if you want to do analyzing of patterns, you can actually do calculate density, or like what we showed you just now, you can create massive space-time cubes. And of course, you can run hotspots analysis as well. So pictorially, this is actually what happens. Essentially, what you want to do is aggregate data. So you must have a target feature, which will be your polygons. You must have features that you want to join to the polygons, which will be all your discrete points. So once you send the command off to the servers to actually run the analytics at the background, it will churn out intermediate results and finally deliver the final results through the portal back to your end product itself. And of course, like we were saying just now, if you are familiar with the environment, spatial analysis is not new. What the geoanalytics server gives you the power to do is actually to run temporal analysis in addition to spatial analysis, all within one tool itself. Okay, so let's take a look at this. This is actually another example of aggregation of lightning strikes at 6-hour intervals in the USA. So if you didn't really catch that, this is a screenshot of what was happening. You notice that we are showing you actually 3 different aggregations. On the left, you have the square. The middle, you have aggregation into hexagon bins. And on the right, what you have is actually aggregation into the county zones itself. So as you can see, within one tool, I can actually do the same analysis, fire it off to the server, and get back 3 different kinds of aggregation and binning. As we mentioned, the additional power that you have is actually doing something what we call time slicing or time stepping. There are 3 important parameters that you need to define if you want to do a time analysis as well. First off is an interval. So example, you have a lot of data, and you want to do an analysis of all your points and aggregation, all for 1 hour intervals. So all you need to do is tell the tool to actually aggregate everything into 1 hour intervals. Let's say, for instance, the second parameter that you can define is to actually say, I want to do the analysis only after a repeat of XX hours. So let's say I have data for 24 hours. I want to repeat it every 12 hours. So how much data do you think you're going to get back in terms of the aggregation? Just 2 sets, right? Because I repeat every 12 hours. So the third parameter that you can actually specify is what we call a reference time. Essentially, you can imagine if you have a lot of data, and I don't want to start from the beginning all the way to the end, like what Lincoln was showing you just now through all the time split data. So essentially what you can do is, for your whole range of data, let's say for 1 month, and I'm only interested in analyzing anything from the 15th of the month, all I need to do is tell the tool to actually just start the analysis from the 15th of the month. The tool will just take in the time slice parameter and start the analysis from there. This is also actually one of the other tools that you can use to aggregate points into tracks. It's actually called reconstruct tracks. It will let you summarize time-enabled points into tracks. So let's say you are running a big event like marathon, where you want to track every single runner, perhaps maybe to check whether they were staying on the route or out of the route. You can actually just track every single runner with this tool itself. So let's go a little bit deeper. This is what we're going to look at. Let's see what kinds of data you can actually analyze. Like I said just now, you can actually use your existing GIS data. That means data that already exists inside your web GIS platform. Or you can use your big data sources, which can sit in big data file shares, or they already exist in your external big data storages like HDFS or Hive. And like we said just now, all the output is actually through your portal. It's a hosted feature service, and it's stored inside what we call a spatial temporal big data store. That is a back-end storage that is designed to actually optimize the performance and storage of large volumes of data so that you can actually do quick quick retrieval and quick search. How do you actually access your data storage locations? First off, you actually need to register this to the server. So you can see that there's a item there that says Big Data File Share. Essentially, what you need to do is to choose one of them, either a file share, HDFS, Hive, or Cloud Store, and provide the connection string and the path to the location of the data. And the system will actually generate something called a manifest file, which is actually just the data schema of the data it is. And in terms of architecture, how can you implement this? So in simple terms, right, the geoanalytics server is an extension of your ArcGIS enterprise. All you need to do is register your big data store, such as Hive or HDFS, which will then send all the processing into the underlying Spark component to process, and the results are saved into the data store and delivered out through the portal itself. So pictorially, let's go. This is how your data is going to move from your data storage, either user managed or GIS managed, goes sent to the farm, geoanalytics server farm, process, sent to the spatial temporal big data store, and comes out delivered through the portal for your consumption in your desktop environment or through a web browser itself. So, in summary, where will that actually lead you? Why would you want to use ArcGIS Big Data Analytics? The ArcGIS Big Data Analytics is actually out of the box and is really ready to use within your ArcGIS system itself. It comes with familiar interfaces. It's simple interface. It's actually all guided GUIs. It actually provides you faster prototyping, R&D, so that it actually gives you insights into your data. You can spend your time doing analysis more than churning of the data itself. The whole idea is to actually make big data easier to use and easier to share by focusing and emphasizing the parallelizing processing power that the geoanalytics server farm will run for you. So what we have actually used to churn out the data and show you the results is actually this whole set of components. We had an ArcGIS enterprise platform set up. Hooked up to that is actually a geoanalytics server farm. And of course, hooked up to that is the spatial temporal big data store, which will store all the information. And we actually ran all the commands through the geoanalytics tools using ArcGIS Pro. And of course, we have to thank LTA Data more for providing the information on the speed data, where we were actually calling and churning and storing the information. And if you are interested, there's actually more information on these web pages. They actually go down deep into what is actually how the geoanalytics server is actually set up. And if you're interested in training, we actually do have an online course that you can actually log into to take a look. It will take you through step by step how to set up the whole infrastructure, how to link all the components together, and how you can actually run the analytics from your desktop itself. And we have come to the end of this session.